So, welcome you in today's LeetCode challenge. This is our day 286 on LeetCode. This is problem number 802. Find the eventual safe states. The problem states that there is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by a 0 indexed 2D integer array, where graph I is an integer array of nodes adjacent to node I. That means if the graph has size 6, then there are 0, 1, 2, 3, 4, and 5 nodes. This 1 and 2 represent that from 0 we can go to 1 and 2 like this, from 0 to 1 and 0 to 2. Now 2 3 at one index is represented from 1 we can go to 2 and we can go to 3 as well. So basically this graph is nothing but the adjacency list itself given to us. And a node is a terminal node if there are no outgoing edges. For any node, if there are no outgoing edges, then that node is called the terminal node. Like 5 5 here is called the terminal node because there are no outgoing edges from 5. A node is called a safe node if every possible path starting from that node leads to a terminal node or another safe node. So basically we have to return an array of all the safe nodes and answer could be in ascending order. So what should be the logic behind to solve this problem? One simple logic we can use for this problem is topological sort. In topological sort, we find out that nodes which are basically cycle free. If we start a TFS call from 0, then we can move to 1, and from 1 we can go to 2, but from 2 we can go to 5, but also we can go to 0 as well. So there is a loop in this 0 1 2, and these all 0 1 2 are not now the safe states. So the approach for this problem should be we first calculate the safe nodes. What are the safe nodes at every index? Let's code this. Globally declared a boolean vector named safe nodes. Safe nodes will always contain the size of graph. Initiate in main function safe nodes to size n. Initially, the safe node will contain false at every indexes means these all indices there are no safe nodes yet present. Then we also have to maintain a visited vector in which we mark the presence or the proceed node every time we proceed that. In this 0 means unvisited, One means this is under processing, or means visited, and two means this is processed as well. Now we will start our DFS from int I equals to 0 till I minus n minus 1. We call a function named DFS and give that function the graph and visited array. That function should return a boolean, a bool answer. Let's just copy this from here, mark that. Now let's copy the vector visited and passed it by reference because we want to maintain the changes in visited. First, uh, whenever we come inside the DFS function, we have to mark our current node as visited. So we have first mark our visited of node as 1. Then we have to declare a variable called bool save, which is initially true. Now we have to move on every adjacent elements for every node in adjacency matrix by this. Now we have to check if the given node is already visited or not. If this neighbor node in visited array is 0, like if we start from 0, we first go to 1 and check if this 1 is already visited or not. If this is not visited, then we have to just maintain, is there any path from this which leads to a cycle in that. So we have to maintain an AND operator for this and call DFS function for this functions, this nodes adjacency, like this. Also, if this condition is not true, so we have to check if the node is visited yet or not. And if we found any node is already visited, then we can directly access whether it is a safe node at that index or not using the isSafe vector. Also, we have to check if that node is processed or not. If it is a processed node, then we have to check for all its path, whether those paths are safe or not. And we can calculate this by our pre-compute answers, our previously pre-computed answers for the node like this. And whenever we found no cycle detection, and this will lead to a function call goes to a terminal node. So from there, the function should be backtrack to its previous position, returning a true bool safe variable. So whenever we backtrack to our initial positions, we have to mark those positions as safe node, and those safe nodes should also be marked as proceed in visited. So this problem is looks like a bit of memoization type NDP. In we calculate our pre-compute results and store them in a vector so we can use them further for our use. Now we have to just move on our is safe nodes vector and check if there is any node or any index at which the is safe nodes equals to false. If is safe nodes at any I is false, that means that node is not safe, and if it's true, then this needs to be pushed in our answer. So we push back the that index in our answers, and finally we can return our answer. Let us check if it's run fine or not. I made a slight mistake, spelling mistake. What is safe node? Yeah, it is running fine. Let's just submit this and check if it is passing all the test cases or not. Yeah, it is passing all the test cases, and this will bind up our video for today's LeetCode challenge. Thank you so much, guys, and please do subscribe and follow for further POTD questions. Thank you, guys.